All right, welcome back, guys, to another economics lecture video. In this one, we're going to be talking about the spending multipliers. This is a concept in economics that features something called the multiplier effect, and it has a couple of different types. And this one specifically is the spending multiplier, and it has everything to do with that long run aggregate supply, short run aggregate supply, and aggregate demand graph that we've been working with. But we are going to get into a little bit of math. So let's jump right in. All right, so the learning objectives for today, we're going to define the expenditure multiplier. This is just another way of saying the spending multiplier. So again, expenditure and spending are synonymous. The marginal propensity to consume and the marginal propensity to save. So these are three things that you're going to need to know. Each one has their own formula as well and use, obviously. So you should, before the end of this video, know the formula for each one of these three things and how we use them. And then we're going to explain, using them, how changes in spending leads to changes in real GDP. So remember real GDP on the aggregate supply and aggregate demand model. Changing spending will change output, and then calculate how changing spending will lead to changes in real GDP. All right, so according to the aggregate supply and aggregate demand model, if the economy is in a recession, like we have in this picture over here, there are two ways of getting out of it, and you can kind of just picture it by looking at it, right? One way of getting out of the recession and putting us in long-run equilibrium would be to increase the short-run aggregate supply like this. All right, if you were to increase the short-run aggregate supply, right, that would put the short-run, it would decrease the price level, right, increase the output, and that would put us back at full employment. And in order to do that, you would need to increase the quality or quantity of production, or get easier availability and access to resources, right? Those are the things that are going to shift the short-run aggregate supply to the right. But in economics, that stuff is hard, and it kind of rarely happens. It happens slowly over time, but for the most part, shifting the short-run aggregate supply to the right is not something that's necessarily easily done, at least in comparison to the other method of getting us out of a recession. So short of shifting the short-run aggregate supply curve to the right, the other alternative is to shift the aggregate demand curve to the right, like this. All right, and this could be done by increasing consumer spending, business spending, government spending, or foreign spending. And that would put us back at full employment, right? It would increase the price level, so there would be some inflation, but it would increase our output, and unemployment would go down, and we'd be back at full employment, which is a good thing, right? That's where we want to be in our economy. And increasing aggregate demand is a more volatile thing to do, which is to say that increasing aggregate demand is an easier thing, right? It changes in an easier way than the short-run aggregate supply curve would change. So increasing aggregate demand, we identify as the easier way of getting us out of a recession than increasing short-run aggregate supply. But if you increase spending, right, which would shift the aggregate demand curve to the right, in economics, when you increase spending, you run into this thing called the multiplier effect. All right, the multiplier effect is going to sound very, very weird at first, but it's so stupid that it makes sense, kind of thing. The multiplier effect is the idea that if you were to increase spending by a single dollar, the resultant total spending would be greater than $1. Okay, and so that sounds absolutely insane, right? If you were to spend, if somebody gave you $1 and then you spent that dollar, right, you would suggest that total spending increased by only $1. But in economics, a bunch of very, very smart people thought about this for way too long, and they concluded that $1 spending does not result in $1 increase to total spending. It has a greater than $1 increase to total spending. So, of course, how in God's name does that happen? And the answer is that spending becomes people's income. Okay, so if you recall, we talked about the spending approach and the income approach of calculating GDP, and that they always equal each other. But if you remember the circular flow model, we identified, right, that households earn money through income, and then what do they do with that income, right? It becomes more spending, and then that spending, right, the money goes back to businesses, which then becomes more people's income. So when you spend $1, right, that dollar becomes somebody else's income, and then they take that dollar and then they spend it. So now you have $2 of total income, right? You started with $1 of spending, but now there's $2 of spending. And then that becomes somebody else's income, and then they spend it. So now you have $3 of total income. And so we have this multiplier effect where $1 of spending results in a greater than $1 increase in total spending. So let's do a terribly drawn example. All right, here we have 4 people that are going to show us how the multiplier effect kind of works. And we're going to start here with person A. And person A has $10 in their pocket that they're going to spend. And they're going to spend this money on person B. Okay, so person A gives $10 to person B, and now that $10 of spending is the beginning of this cycle, right? $10 of spending, so total spending is just increased by $10, and that became $10 of income for person B. Now, person B has a couple of options with these $10, right? He can, and this is just a truth that we're going to come back to here in a little bit, that you can only do 2 things with money, right? You can either save it or you can spend it. All right, so person B has $10 in his pocket now, and he's going to, let's say he's going to spend $8 of it, and he's going to save the remaining 2. So person B is going to spend $8, and he's going to give those $8 to person C for some good or service. All right, and he's going to keep 2. So that's $8 of spending now. All right, person C now has $8 of income. Okay, and of course, again, what is person C going to do? Well, let's say that they keep $2 as well, and they spend $6, and they give those $6 to person D, and then person D now has a $6 income. All right, and then they keep $2 and they spend $4 on something else, whatever. Okay, and then the cycle obviously continues until the last person gets the money and then doesn't spend it. So the question is, how much did total spending increase? We started with an increase in $10 of spending, but how much did total spending increase? We have the $10 of spending from person A, the $8 of spending from person B, the $6 of spending from person C, and the $4 of spending from person D. And so the total spending has increased by $22. So we started with $10, but because of the multiplier effect, total spending increased by $22. Sounds crazy, I know, but this obviously has an impact on the macroeconomy. All right, and what this means is that real GDP increases and decreases at a multiplied rate with changes in spending. So that could be consumer spending, business spending, government spending, foreign spending. Whoever's doing the spending, it doesn't matter. But if you change one of those spending, so in this graph over here to the right, we have an increase in spending. Let's say it's government spending, right? The government increases its spending. The increase in spending in and of itself will shift the aggregate demand curve to the right, from AD1 to AD2. Right? That's just the change in spending. But because of the multiplier effect, it will have an increased effect, right? An exaggerated effect on the overall change in spending. So that would push the aggregate demand curve even further from AD2 to AD3, right? So the multiplier effect has this increasing effect, and it can happen in the opposite direction too. If there was a cut in spending, if consumers stop spending. So if in the same example, if we had person A who usually spent $10 decided to cut back $10, and that would be $8 that person B wouldn't spend, and was it $6 that person C wouldn't spend, and so that would actually be a decrease in spending of $22 at a multiplied rate. So that's the multiplier effect, and you can see how it has this impact on the aggregate economy. So the determinants of the multiplier, right? As we said before, you can only do 2 things with the dollar. You can consume it or spend it, or save it. Now, I should point out in other economics classes in the world, like if you take a finance class, they'll say, well, you can invest it, or you can do all these different things. But in purely simple terms, and investing just counts as spending, right? In purely simple terms, you can either hold that dollar or you can give it up for something. And so what makes the determination of the multiplier effect, right? The multiplier will have a larger or a smaller impact on real GDP in total spending, depending on 2 things, right? The marginal propensity to consume and the marginal propensity to save. All right, these are also known as MPC and MPS. All right, and essentially what these are going to tell us is the marginal propensity to consume is the amount of a given dollar of income you would spend. So if you think back to our earlier example, person A was given $10, right? That's a given amount of income, and he spent $8. So his marginal propensity to consume, right, was 80%, right? He consumed 80% of those $10. And that was the $8 that he spent. All right, and then the other side of it is the marginal propensity to save, which is the amount of a given dollar of income that you would save. So in the same example, person A saved $2, which is 20%. So his marginal propensity to consume in the first example was 80%, and his marginal propensity to save was 20%. All right, and these will determine how much the multiplier effect has on the change in spending. So let's go back to this example and change it around a little bit using a change in marginal propensity to consume and marginal propensity to save. So if you remember the last time we said that person A spent $10, right? So we started with an increase in spending of $10, when person B decided to save $2 of his new $10 income and spend $8 on person C, and then each person after that saved $2 and spent the remainder. Well, what if we change the marginal propensity to consume and the marginal propensity to save? What if each person instead only saves $1? How would that have an impact on total spending? All right, so let's take a look here. Person A starts with $10, right, and he's going to spend $10 on person B, so we start with an increase in $10 of spending, and so person B has $10 in income, so that's all the same. But the marginal propensity to save now is $1, for example's sake. So that means person B is not going to save $2, he's only going to save $1, and he's going to spend the remainder, which is $9 now on person C. So person C now has $9 of income coming to him, and he's only going to save $1 as well, and he's going to spend the remaining $8 on person D. So person D now has $8 of income, and then person D, of course, is going to save $1 and spend $7. Okay, so now what is the impact on total spending? So we had the $10 initial spending, person B spent $9, person C spent $8, and person D spent $7. So that's $34 of total spending increased. In the last example that we did, we saw that total spending increased by $22, and now total spending is increased by $34. So marginal propensity to consume and marginal propensity to save determine how much of an impact the multiplier has on the multiplier effect of total spending, because they both started in the same spot. They both started with an increase in $10 of spending, but they ended in different spots. In this example, with a lower marginal propensity to save, we saw the multiplier effect have a greater impact on total spending. So the higher the marginal propensity to save, the lesser the impact, and the lower the marginal propensity to save, the greater the impact. Okay, so we can take these concepts and put them into formulas. When we measure MPC and MPS, right, we are using them to measure the marginal portion of income that's spent or saved. Okay, so when your income increases, right, let's take person B for example. Person B in the first example was given $10 in income, right, and he obviously chose to spend $8 and save $2, and that determines his MPC and MPS. But we don't measure that necessarily in percentages. So you wouldn't say that his marginal propensity to consume is 80% or his marginal propensity to save is 20%. Instead, you measure MPC and MPS by marginal portion, which makes sense because we're all talking about marginals here. And marginal, if you recall, is kind of a term that means the increase or decrease of one more. So when we're measuring MPC and MPS, we are measuring how he spends a single dollar of increased income. All right. So if we gave person B $1 in income, right, how would he spend that $1? Well, considering what we know, person B would logically spend 80 cents of that dollar, right, and save 20 cents, because that's effectively what he did with his $10, right? He saved 80 cents for each dollar that he earned, and he saved 20 cents for each dollar that he earned, and he spent 80 cents for each dollar that he earned. So when we identify MPC and MPS, it's normally a number that's less than 1. So for example, for person B in the first example again, his marginal propensity to consume per dollar was 80 cents, so that'd be like 0.8, and then his marginal propensity to save was 20 cents per dollar. And then when you add MPC and MPS together, they always equal 1. All right, and this 1 here represents each increase by $1 of income. Right, so his income went up $1, he spent 80 cents, and he saved 20 cents. So MPC and MPS are always going to be some kind of decimal number less than 1. All right, and then you can calculate MPC from MPS, obviously, by just subtracting it from 1. So MPC is just equal to 1 minus MPS. So in this case, 0.8 would equal 1 minus 0.2, or MPS, which is 0.2, would equal 1 minus 0.8. Okay, so generally when you get a question related to multipliers or this kind of concept, you'll be given either the MPC or MPS for these calculations. But it's important that you understand essentially what is the MPC and MPS telling you. Like if I told you the MPC is 0.8, then you should know that for this person or in this economy, for each dollar of income earned, people spend 80 cents. Okay, so that's essentially what we're measuring when we identify MPC and MPS. So this all takes us to calculating the spending multiplier, which is identified here as this M sub S. And the spending multiplier measures how much a change in spending changes total spending, or real GDP, using the marginal propensity to save and marginal propensity to consume. So this is going to be a useful thing to essentially find out how much does total spending change when you change a level of spending. All right, so it's going to be kind of a shortcut for us to find out, okay, when person A spends $10, then you can just use this to find out what will be the end result without having to go through all the steps and the processes. So the spending multiplier is calculated as 1 over MPS. All right, or if you're given the MPC, then you have to find out the MPS by subtracting it from 1. So the spending multiplier could also be 1 over 1 minus MPC. So if the marginal propensity to save is 0.1, right, which means that for every dollar that's earned in income, people save 10 cents of it, right, then what's the spending multiplier? Well, it would be 1 over 0.1, which is just 10. All right, when you plug that into a calculator, it comes out with 10. So the spending multiplier in this case is 10. All right, now let's try some other ones. What if the MPS, all right, the marginal propensity to save, is 0.25, which means that for every dollar earned, people are saving 25 cents. All right, well, to find that out, you just put 1 over 0.25, and that'll come out as 4. So the spending multiplier is 4. All right, what if the marginal propensity to consume is 0.5? Now, this is a little tricky, right, because the formula for the spending multiplier is 1 over MPS, and I've given you the MPC. So all you have to do is use this formula over here, and it's just 1 minus the MPC, which is 0.5, so easily enough. It's just going to be 1 over 0.5, and that should give you 2, right? So the spending multiplier is 2. Okay, so what does this mean? Let's take a look. So when you calculate the spending multiplier, this is going to be your tool to find out the overall impact of a change in spending on the total spending, or real GDP. All right, so we have this formula here that's going to be very, very useful moving forward. All right, so this is going to help us calculate the overall effects on real GDP from a change in spending using the spending multiplier. So the formula is just the spending multiplier times the change in spending, and then that's going to give you the change in real GDP, or the change in total spending. All right, so remember, right, this change in spending, right, spending can be either consumer spending, business spending, government spending, foreign spending, any kind of spending. So the formula could also be written like this, right, the spending multiplier times the change in consumption or consumer spending equals a change in real GDP, right, the spending multiplier times the change in investment spending is going to result in a change in real GDP. All right, over here we have the spending multiplier times government spending equals a change in real GDP. And then also we have the spending multiplier times a change in net trade, or foreign spending on resulting in a change in real GDP. So all these four things are all the components of real GDP. And one of those changes, you can multiply it by the spending multiplier, and then it'll tell you how big of an impact it'll have on total output, total spending, real GDP. It's all the same thing. So let's do an example question. Here we have an economy, and we're assuming that investment spending increased by $5 million over the last year, and the MPC is 0.8. Okay, and so the question is, what would be the total impact on real GDP? All right, so the way we're going to figure this out, right, we have to first find out what the spending multiplier is. And we can start, really, if you want, with the original formula, and then just kind of fill in as we go. So the original formula in this question, it's talking about investment spending. So we're going to have the spending multiplier, right? We don't know what it is yet because it wasn't given to us, times the change in investment spending. So we'll just write out the whole formula first, equals the change in real GDP. Okay, and now we can plug in some of this information. So we don't know the spending multiplier yet, right? Times the change in investment spending, which we can see is an increase of $5 million. So we'll just put 5 and we'll put a little m for million, okay? And then equals, and the question is asking for the change in real GDP, so this is X, right? This is what we're trying to figure out. All right, now we have to figure out the spending multiplier, and we can do that using the given information of the MPC. So since the MPC is 0.8, right, then we can figure out the spending multiplier, because the spending multiplier is 1 over the MPS, or 1 over 1 minus MPC. So in this case, 1 minus MPC is 0.2. So the spending multiplier is 1 over 0.2, which would give you 5. Okay? And so therefore the formula is just 5, which is the spending multiplier, times 5 million, all right, equals, and then that's going to give us a total change in output of $25 million. Okay, so what is that going to look like on the graph? Well, we know that an increase in investment spending is going to shift the aggregate demand curve to the right, but how much, right? Well, what we now know is that the aggregate demand curve will shift to the right, and this new level of output that we have here is going to be an increase from the original output that we were at by $25 million. So we will have increased our total output, our real GDP, by $25 million as a result of the increase in $5 million of investment spending. All right, and this is all thanks to the spending multiplier. Originally, the increase would just be $5 million, right? But because of the spending multiplier and people's ability to spend and consume dollars, right, it's resulted in this $25 million increase in spending. Let's try another example. Let's say that the economy is still in a recession, as we see here, and the actual output of our economy in the short run is $180,000. Okay, so you can see here on the graph that there's the $180,000, and that's our level of output in the short run. All right, but we're in a recession, and the potential output at full employment is $200,000. All right, so here's $200,000, and that represents our level of output at full employment. So at full employment, we can produce $200,000 worth of output. So the question asks, how much spending needs to occur for the economy to reach full employment? All right, so obviously our economy is not at full employment right now. We're in a recession, and specifically that recession is the distance between our level of output in the short run, right, that's $180,000, and our level of output at full employment, right? We want to be at full employment, but we're not, and so we're only producing at $180,000. Okay, so how do we get there? Well, you can increase spending, right? Remember, increasing spending shifts the aggregate demand curve to the right. But can you increase spending? Can you just simply increase spending by $20,000? And the answer is no, right? Because if you increase spending by $20,000, sure, that's going to boost aggregate demand to that $200,000 mark. But because of the multiplier effect, it'll blow you way past that, right? So we have to calculate how much to increase spending by in order to return us to full employment. And so we can put the formula in here and just plug in the numbers that we need to plug in. Now it says how much spending, so we're just going to say any kind of spending. So the formula here is going to be the spending multiplier, all right, times the change in spending, and this could be any kind of spending, but we'll just put change in spending, equals the change in real GDP. Okay, so we can plug in some of the information that we know. Now the multiplier is not given, but they give us the MPC. We know that the MPC, that the multiplier is 1 over 1 minus the MPC, or 1 over the MPS. In this case, the MPC is 0.9, so the MPS is 0.1, so 1 over 0.1 is just 10. Okay, so we know that the spending multiplier is 10, and then filling out the rest of the formula times, and we don't know how much spending needs to change, so that's going to be our X, that's our variable that we have to figure out, and then equals the change in real GDP, which we know that the desired change in real GDP, the amount of output that we want to accomplish, is an increase of $20,000. So we put $20,000 here. Okay, and now just using basic algebra, right, you would just divide both sides by 10, okay, and then that's going to tell us that we need to change spending. We need an increase in spending right now of $2,000. Okay, so if we were to increase spending right now of $2,000, right, and then the multiplier effect would boost that essentially times 10, then that would push our aggregate demand to the right to where we increase our total output, right, by 20,000, right, and then that would put us back at full employment. All right, so this is another kind of example question that you can expect to see in the assignment ahead of you. All right, you guys have an FRQ on Canvas, so you can go ahead and do that. And we're almost done with Unit 5. So have a good weekend. I'll see you guys next week.